EViews. Now, before opening EViews, and you got the file, named gold, GOLD, gold price actually. So that is a gold price variable. Okay, just open it and see. Excel sheet named gold. Actually, it is a gold price. So what we are going to do, we are going to forecast the gold price. Okay, using ARIMA. That's what we are going to see. You can use any variable, no problem. But I will tell the procedure how to know how to forecast the gold price using ARIMA. Okay. So first, what we will do is before identifying ARMA. Okay. The first step, we'll find out whether the IR integrated. No, integrated means what? Whether the variable is stationarity at level or it is stationarity as first difference. That is what we are going to find out. Before going to the identify the appropriate P and Q of ARMA respectively. Okay, fine. So how to do that? So there are many, as I told you, there are many unit root tests. The first test is ADF test, augmented Dickey-Fuller test. There are two more tests. Phillips Perron. See, commonly used tests are two. One is ADF, the other one is PP. ADF means augmented Dickey-Fuller test. The other one is Phillips Perron test. So which one to be? It's up to you, because we are going to fulfill the fundamental property of the time series analysis. Okay, fine. So we'll do ADF test and see to it. Any variable you take, and the first procedure is to check the stationarity property, because the stationarity property is going to suggest what type of analysis to be employ or apply to your data. Please remember, this is a very important point. That starting this yesterday is all about the fundamentals which I have explained to you for to get the more clarity on TSA time series analysis. Now, today we are going to do all the the practical, estimate the model. Okay, so all based on the practical today. Okay, so before I will explain certain concepts which are very relevant to the model that you're going to apply. So first one is ARIMA. ARIMA, what is the first one? I told you there is a Box-Jenkins methodology, there is a flow. So first step is identify the selection of appropriate AR and MA. So P and Q, the lag order we need to find out. So how to find out, we'll see. And before that, we should see, the check, the I. I means the integration, the unit root test. No, yesterday I gave explained about the stationarity concept. Okay, so the mean and variance should be stable, and basically it is the time invariant, which the mean and variance of the data set should not change over the period of time. Okay, fine. So that is the basic property. So here the I of the integration of 0, or we are going to check whether the variable is integrated of 1, the first order level. Okay, so if it is stationarity at level, fine. Go ahead with the stationarity data. No, sir, it is the stationarity at the first difference. Okay, if it is not stationarity here, if there is no non-stationarity here, the data is said to be non-stationarity, then go with the first difference and find out whether it is stationary or not. Okay, so first difference, which we call it as delta, which basically represented by delta. You know that, no, differencing the data once. Okay. So open the data, you'll find out. Sir, can I use the okay, you can see share the yeah, audience, I just share the entire screen. Audience, please, there are two variable here. There are two variable. Variable means one is the gold price, only one variable, gold price, and the gold price is converted into returns. So I'm not generating the returns using the EViews. Okay, so directly I'm using Excel sheet, then import the data in EViews. So you got this data? Students, you got this data. Now you can use one computer and share with others also if you found difficult. Okay. See, one is gold price, the other one is returns. We'll find out which one we are going to focus because it depends upon the I. What is I? Integration. Integration, we are going to check whether the gold price is integrated at the zero level or it is first difference. Okay, so what we are going to do, I'm going to open EViews. Okay, so how to open EViews with a data set? Very simple. Just drag and drop. Yes, drag and drop. It is easiest way. Yeah. Just drag and drop on the EViews icon. It will open. Okay, so look at the step here. Don't need to give the further details. Let's just finish it. And I don't want to pull out anything from external source. That's it. Give no by default. So you got this page? Got this page? No? Okay. So here, what is level? I told you level means it's basically a raw data. Raw data. What is the first difference data? It is returns. Returns. First difference means become the return. So you know return formula, right? There are two formulas to calculate returns. Normally here, the share price returns, how to compute. So here one is, let's say YT minus 1 divided by YT minus 1 into 100. That's one way. It depends. The second thing, YT minus 1. There are two ways. Because especially those who are from the finance background or economics, finance and economics, they know how to compute the returns for the share price or stock price or index. Okay. So what we are going to do now, we are going to conduct first ADF to identify whether the integration is in order 0 or order 1. Okay. Madam, you got the screen? You just open this? Yeah. Now, go to quick. There are shortcut method also. It's up to you. Okay. Go to quick and there is a series statistic. You can see unit root. You can see unit root here. Click the unit root. Why it is series statistics? Because the unit root is confined to a single variable, a single series. Correct? No, a series. That is the reason. Okay, it is not, you can't conduct the unit root test for a group of variable. It is for a series. Okay, so what is the series name? Yes, gold price. GO, gold price. Okay. So look at the tab which I got, the box, dialog box which I got. So what you able to see? It is level. First option you see level, first difference, second difference. Okay. Here there are three equations. The ADF, if you look at the ADF equation, there are three equations. The first equation with intercept alone. The second equation is your choice. The second equation is with intercept and trend. It's up to you. Trend means the time trend you are incorporating in the equation. And third equation, no intercept and no time trend. Yt is a function of yt minus 1 without incorporating the constant and the time trend. Very simple. Now, your choice. I don't want to keep a constraint here. So let it be, by default. Don't do anything. And one more thing I want to tell you, especially if you take time series, the lag length plays a major role. The lag length. Please remember, lag length plays a major role. So what is lag length? Let's say, see, this ADF is based on, if you look at the ADF form, the equation of the ADF form, it is autoregressive form. So yesterday I told you, if you look at the ADF equation, unit root test, there is a PPT which I given. So the equation is based on yt is a function of yt minus 1. We are regressing with its own lag. Okay. So now if you look at the form of the equation, it is yt is equal to alpha plus beta yt minus 1 plus ut. The basic form of the AR form, the basic equation. Understand? No. So here, which should be significant? Which should be significant? If it is stationarity, what is null here? The beta. The beta should be equal to 0. That's what we are assuming here. Okay. We are using standardizing, and we are using beta is equal to 1, which is nothing but the unit. In mathematics, we call unit. So what I'm saying, beta is equal to 0, which basically we call it as, this is non-stationarity. Beta is not equal to 1, which is nothing but the stationarity. But I simplified and said the null is non-stationarity and the alternative is stationary. Okay. Now look at this equation. Here you can see the concept. Here it is the concept. But which is important for me? This one is important. The beta coefficient is important for me. Okay. So fine. Just please look at the PDF, the PPT of the unit root which I forwarded. It is a very simplified version. It is based on yt is equal to alpha plus beta yt minus 1 plus ut. Okay. Now let me go with only intercept. I have not introduced the time trend there, the equation. So what I supposed to do? Click OK. Lag length. Yes, sir. One more thing I want to explain. Lag length. Have you seen lag length? What is the number of lag? Number of lag is 13. You leave it to the software, it will consider. Depends upon n. Depends upon the number of observations, it will consider automatically. Now, what do you mean by lag length? Let's say, what we believe today is influenced by the past. So, yt is a function of yt minus 1. Sometimes what will happen? No. Yt also influenced by yt minus 2. We do not know. So when we are regressing it, which leads to loss of information? We can't sufficiently capture the information. It leads to loss of information. Understand? So, sometimes no. Yt is a function of yt minus 1, yt minus 2. Then yt minus 8 also will have sometimes influence. We do not know that. Understand? No? So, all possibility we have to look at it. So, this, actually there is a procedure for identifying the lag length that we'll see when we are doing in VAR model. Okay, let us finish this first. So, now the lag length selection I have given to there are different criteria to identify the lag length. The SQUAS information criteria, KK information criteria, the different criteria. By default, it is mentioned SIC. Sir, can we keep AIC? No problem. You can also identify through AIC. Okay. So now just click OK and see the result. I'm maximizing the result. See the result, audience. Okay. So please see the result. Here, look at the t-test. T-test. So augmented decay test is based on the t-test. So what is the value of t-test? Minus 0.620. Okay. So now I am comparing with the probability value. What I told you yesterday, the probability value. If I want to reject the null, the probability value should be less than 0.05. We kept the benchmark. So don't, sir, why can't be 0.01? Why 0.1? I mean 0.1. 0.01 and still within the limit of 0.05. Anyway, sir, can we go for 0.10, 10% level? It's up to you. You take a call because I want to go for 0.05, 5% level of significance. Okay, look at here. The value, the probability value is greater than 0.05. So what is the inference? What is the inference? What is null? Non-stationary. What is the alternative? Stationary. Now tell me, student. Is it variable is stationary or non-stationary? At level. It is non-stationary. It's clear now. It is non-stationary. So what we are going to do? We are going to difference the data. So now I'm going to difference the data to prove it. One more thing. Look at the equation below. I told you, no. It is using the lag. It is using the lag. So look at the equation here, the ADF test equation. You can see the dependent variable. And also you can see the regressors. Regressors means you can see the lag of gold price with the first difference term also is there. Constant. This is with constant. This is a specification. Anyway, what is our decision making here? What is the main key output here? The gold price is non-stationary. We are going to convert. We are going to prove it is going to be stationary. So what is the next step? Okay. What is the next step? We are going to go for the differencing. Okay. Good. So now how to do it? Very simple. Click view. Have you seen the view button in the corner? Click view. Okay. Click view. This is, I told you no yesterday. It's a conventional unit root test. The conventional unit root test. Standard unit root test. Click here. Okay. Now first difference. You no need to convert into first difference. The EViews will automatically consider the differencing data. Okay, first difference. Click first difference. Click OK. Click OK. Yeah, now you look at the result, the t-test and the probability value. T-test and the probability value. So what are the inference now? Yeah, the data is stationary. Yeah, you can use, I told you there are two. Yesterday I told you there are two ways. One is you can either use the probability value or you can go with the standard, the critical value. Critical value is given down below. These are the critical value. See here, sir. Have you seen the critical value at 1% level? Minus 3.469. That is for 1% level. 5% level, what we are fixing? 0.05. What is the critical value? Minus 2.878618. You can also compare. Compare with what? Calculate. No. Probability value is different. T value is here. Okay. Now you see 15 point minus 15.52. Ignore the sign. The T value is always in the module. Module means it's ignore the plus or minus. Only the absolute value will be considered. What is the absolute value T here? 15.52. That is the calculated value. What is the critical value? Tabulated value? 3.46. Which is greater? Which is greater? Calculated value is greater than the tabulated value. Hence, reject the null, accept the alternate. This is one way. This is one way of interpretation, inference. Otherwise, I told you very easiest way is probability value. Keep the benchmark value 0.05. Sir, can we go for 0.10? Yes, that's up to you. I told you. I don't want to make a constraint there. Okay? Either you can compare with that is the advantage of ADF test here. Not only even Phillips Baron also. These all unit tests, they comes out with the critical values. Okay, critical values. You can see here. Down. These are all critical value. Either you can compare. Sometimes no. Sometimes very difficult to, I'm telling you, practically what will happen, the data which you're downloading, no? The probability value, sometimes you'll get 1. I have seen this case. 1. The probability value 0 and 1. So what to do? Little there is a suspect, okay, what to do? We can't do anything. Or sometimes we'll get 0.99999, we'll get it. If you are suspect, no, if something wrong, maybe this is what the data you collected from the authenticate source. Directly we run the ADF test. So if you are suspecting, okay, the probability value is 0.999 or maybe you are getting exactly 1. In that scenario, you can go with the critical value. Compare the critical value and the table, the calculated value and the critical value. That's what you can do it. Okay. So what is the conclusion here? The data is stationary. Whether it's I of 0 or I of 1. I of 0 or I of 1. Yeah, the data is integrated of order 1. Why I am saying it is order 1? We are using first difference to convert into stationary. Otherwise, I told you, the result will become spurious. If you see in this case, you should perform the econometric analysis using the first difference data, not with the level, raw data. Understand, no? But there is a co-integration analysis. Normally, there is a co-integration analysis, a kind of model. For the long run, we are using this level data, even though it is non-stationary. That is, still you can do because that is proven mathematically, especially for the co-integration. That will come later. Okay, so first, we have to make the data stationary for the further econometric treatment, that analysis. Okay, fine. So we got I is equal to I of 1. So what you can do is, you can test with intercept and trend for your exercise. Okay, and find out, is there any change in the results by changing the equation. How to change the equation? You have to do, what you have to do? You do it for the practice. Start again. Find out the stationarity at intercept and trend. What is the result? You got it, no? What I'm saying? You redo it and tell me your outcome, the key findings, using the equation of intercept and trend. I want level and first difference. both level and first difference, I want to see whether the data is stationarity or not. Done it. First difference only. Using which equation? Intercept and that means incorporating the trend along with the constant. Very good. This is no practical exposure to you. Sir, is it I need to go only with the trend or maybe no? I mean, can I go with only intercept or can I go with only intercept? It's up to you. But I want that data should be proven stationary. Okay. I think you are getting the same result, no? That's okay. That doesn't matter for us. We want to be proven the data should be stationary. Okay, audience, please. You just do it and see. Okay. The steps which I followed. Okay, so I will do it again. Go to quick, series statistics, unit root. What is gold price, right? Gold price. Okay, level. But what is the equation? I want to test with the equation incorporating and including the trend and intercept. Click OK. Okay, the data is non-stationary. The data is non-stationary. So what I have to do? Check with the first difference. Go to view, unit test. Okay. Just go and first difference. I'm going to use the first difference data because already the levels it is non-stationarity. Just click OK. Now you see the data become stationary. So either you can construct the equation with the intercept and trend. So this is about the stationarity test. Anything. That's what I'm keep on telling. Anyone you can choose to prove the stationarity. There is no compulsion there. You have to. Some people conducted both. Intercept, then separately intercept and trend. That is also fine. Up to you, sir. You got the results. See, one more thing I'm telling. This is a very important point. You have to conduct unit truth for all the variables that you are using. So how many variables you are using? Here I'm using only one variable. Suppose I deal with the two variables. For both the variable, you have to conduct the unit root test. Means stationarity test. Sir, I'm using 5 variable. All 5 variable, you have to conduct the unit root, I mean stationarity test. Please. There the problem starts. The economic procedure, no, econometric procedure starts from the unit root test, the stationarity test. So what is starting point? Starting point of the econometric techniques, the procedure is stationarity test. So today, I hope you are you got clear about the stationarity test. Now, this is a basic. Now you also know how to do it, right? Okay. So now I found AR. Sorry, the integration I. I'll come to AR later. So I got I is what is I? The data is stationarity at order 1. Integration of order 1. So what data I have to use? I have to deal with I have to forecast the data using which data? For the returns, not with the price. Sir, later can I convert the return into price? That's up to you. That is the procedure. Now you have to forecast the returns. You can't forecast the gold price because we are not using ARIMA. We are using ARIMA. First you forecast the returns. Can I convert the returns into the actual value? The price, that's up to you. That is the procedure. In Excel also you can do it. So you have to forecast with the returns. Forecast using the returns. So now we found I is 1. Now how to identify? Students, I will come and check. I will come and check your system. Okay, I want to see the results. Can I come? I want to see the results actually. I'll raise the question as well. Okay. Very important. It will be useful for you. It will be definitely going to be useful for you. Okay. Next step, we are going to identify AR. What is AR? What is AR? Auto regressive term. But we have to be very careful. The lag length is very important. I told you, no, lag length is very important. Whether the AR going to be 1 or AR going to be 2 or AR going to be 5 or 6, we do not know. We do not know. So we are going to identify the appropriate lag length of AR. So how to find out? Similarly, MA also, how to find out? That's what I'm going to explain now. Okay. Go to first one. Go to quick. Go to quick. Estimate equation. Estimate equation. I told you which data we supposed to use? Gold price or R? Or returns. Because returns is the first difference data. First difference data, which is already provided in the Excel sheet. Otherwise, you can also compute. So how to compute? You want that part? I will explain. How to convert the returns. No, the first difference in Excel. Open the Excel sheet. Okay, open the Excel sheet. Okay, gold price. This is return. So how to do it? The first information we won't get it. The first information we won't get it. When we convert it into returns, we won't get. Why? Because there is no previous value. So what we supposed to do? Just ignore which is equal to the next observation, which is equal to present minus, I just open the bracket, present minus a previous value. Okay, so we got 10.4. The difference between the present value and the previous value. So this ultimately leads to loss of information. One observation will go off. Now just drag it or double click. Now you understood, no? How I got the returns. How I got the first difference of the data. Got it, no? So already they made it ready, then I have just kept it by default. Okay. I'll just close this. This is first difference data. Just open the EViews file. Open the EViews file. Now go to estimate. Now I go to estimate to identify appropriate AR. Okay, so what is the dependent variable? What is the dependent variable? It's not gold price. Yeah, it should be very good. It should be returns because that's the first difference data. No, I told you, no. The returns is stationarity. The stationarity and gold price is non-stationary. So, RETU has come already. Just double click it. What are you supposed to do? C space AR1. What is AR1? Auto-regressive of lag length 1 space MA1. MA1. You understand, no? 1. AR for UT minus 1 and MA for, sorry, AR is YT minus 1 and MA for UT minus 1. UT minus 1. Yesterday I specified the equation. Now what we supposed to do? Estimate it. Click OK. Which method I'm using? Which method? No. What is this method I'm using? Below you can see. Very good. Ordinary least square method. Regression, simple regression model. We call it as the OLS model, right? Ordinary least square method. So click OK. Got the result, no? So ignore sigma, that is with available with the recent packages. Okay. That is basically the risk factor also coming out with it. Leave it. Now look at ARMA. Look at ARMA. AR is first step. What is the t value of AR? Can anyone tell me, is it AR is significant or not? Sir, is it board visibility? No. If I use a board, they could able to see, no? Okay. Now, it's a very important, the observation here. So what is our specification here? What is our specification here? Audience, what is our specification here? Delta YT is equal to alpha. What is alpha? Here I am using alpha. No, yesterday I used A. Here it is alpha. It's in the notation, doesn't matter. Alpha plus beta 1 y delta YT minus delta YT minus 1 plus beta 2 delta. Very good. UT minus 1. So UT minus 1 plus UT. Still you have to, don't forget the error component. This is very important, UT. Okay, fine. Got it? This is the equation which I have estimated. Now what you have to observe here, which is AR here? Which is AR? This is AR. And this is MA. AR, MA. So what you supposed to do? You have to find out which both, there is a necessary condition here. What is the necessary condition? Both terms should be significant. The first condition, the both AR and MA should be significant. If it is not significant, anyone is significant. Sir, MA is significant, AR term is not significant. This is not a good model. This is not an appropriate model to forecast. It's not an appropriate model. Understand? No. Suppose, sir, AR is significant, MA is no. Both the concept should be, both the variables should be significant. Now, look at our results. The results which you got. Look at the result we got. Okay, so what is your observation? AR term. This is which model? This is which model? AR AR, which model here? AR ARIMA. Which model is this? 1, 1, 1. So AR1, order of integration 1 because we are using the first difference data. The last one is first. Okay, can I accept AR11 for forecasting? Can I accept AR11 for forecasting? Can I use? Why? Both are insignificant. Beta 1 and beta 2. So this is not parsimonious model. Okay, now you try AR ARIMA. ARIMA, you try, you estimate. 2, 1, 1 model. You try it. You know how to estimate now. So second model. Third one, you try ARIMA 212 model. Sir, it takes half an hour time to identify. Sir, it takes half a day. No problem. You try. You have to do this experiment to identify. There is a one more step is there, very important. This is the first step actually. Okay. The fourth model, I want to see ARIMA 313. Fifth one, I want to see ARIMA 312. One more 311. Sixth model, ARIMA 311. Why you have to do it? It's all trial and error. Just go ahead. ARIMA, seventh model, I want to see ARIMA 222. Eighth model, I want to see ARIMA 333. Because already I have done this exercise, so I just know cut short it and I give you for the testing, for the estimation. Okay, so how many model you need to estimate? Already we have done one model. How many you have to do? Remaining seven estimation. Just estimate and see and tell me, sir, in that particular model, both the AR and MA are significant. Just tell me that variable. Just tell me that model. I want to know. Look at here, ninth one, 616. You have to try this, 616. Because I have done an exercise. And identify. That is what I have given. I just know. Precised it. Briefing. Just know. Only 9 model I have given. Already estimated one. Okay. Anyone tell me the first model already estimated. Both are insignificant. Correct? No, here in the board, no, not sorry, in the EViews output, you see both the variable are insignificant. Okay. What about second model? Now I'll go to the students here who are sitting here. I want to check. The second model is fit or not. It's a good model to be considered for the forecasting or not. I'm going to check. Tell me, students, in second one. EV is working, no? EV is working, no? What is the problem? You have data. Drag the data. Go to quick. Estimate equation. One more thing. One more question. Yeah. There is one valid question will be there. Sir, I'll explain with the 2. I'll explain with AR211. Sir, how to go for AR211? Yeah. I am sharing the screen now. Just look at it here. Go to quick. Go to quick. Otherwise, go with the. Oh, you are muted now. Is it audible now? It's okay, no? Now? Because already now I just unmuted it actually. No issue, no, sir. Don't have any problem. Okay. See here, go to quick, estimate equation, estimate equation. How to specify ARIMA 212 returns? C, AR. Very good, very good. AR2 space MA1. Click enter. Delete and delete this equation, no problem. Existing one. Wow, very good. So what is the problem here? What is the problem? Anyone? What is the issue with the output? MA is significant and AR2 is insignificant. Insignificant. So we don't want to consider this model. We don't want to consider this model. So that I'm going to strike out now. The second one. I'm going to strike out this. Now, third one. The third one. Can you go for 212? Can you go for 212? AR2, MA2. Can you go for 212? Estimate. Two and two. Both are significant. Okay. ARIMA 2 and 2. Both are significant, right? Actually, this is a process. Take some time, but you are learning. AR 2 and 2. Look at the probability value. Forget about the coefficient. Look at the coefficient. I mean, the t value or the p value or p value associated with the coefficient of AR1 and AR2 and MA2. So both are significant, right? Both are significant. So can I consider? Can I consider this model? Okay. I'm just make a tick. Sometimes there is a problem. What's the problem? There is a loss of information. Sometimes 313 will be both the coefficient are significant. Who knows it? We have to try it. We have to properly try it. No, that's the appropriate way. Then go for 313. So 212 is okay. Accepted one. Accepted model. Accepted ARIMA model. Go for 313. 313. 313. Tell me whether the both coefficient are significant or not. 313. Oh, MA is insignificant. Okay. AR is significant. MA is insignificant. I don't want this model. It's not an appropriate model. 312. Quickly, 312. Easy. Just change the now value, no? The numerical no? Value. And 313. Sorry, 312. 312. Tell me the answer. Yes, sir. Okay, so 312 also. 311. Okay, which is insignificant, sir? 311. Oh, all significant. Very good. 311. We'll go for 311. So, this is also an accepted model. Now, can go for 222. Both are significant. Oh, no. Sorry. ARIMA, it's not 222. Actually, I is fixed. I'm sorry. I didn't notice. Yeah. Always in the middle value should be always 1. Because first difference, no, that cannot be changed. Anyway, 212, all significant. Very good. This is what I want. So how many accepted model? 1, as of now, 1, 2, 3, 313. This is I have specified 2, 1, 1, 3, 1. You have to look at all the possibility. 313 already we did, no? Then go for 515. Go for 515. Go for 515. Huh? Insignificant. 414, 414. Last one, 414. ARIMA. 414. All the possibility. We are checking for all the possibilities, right? So can we accept this 515? Can we accept 515? பரவாயில்ல பார்டர்ல தான பிரச்சனை இல்லை. It's okay. It's not about the border. If it is less than 0.05, it's okay. So can we consider 515? So both AR and MA is are insignificant. So we'll go with 616. I think 61 is the best model. No. I thought, okay, we'll go with 616. 414. The last one, 414. Insignificant. Both. Okay, so how many models are appropriate in forecasting the gold price? So how many models out of 10? 3. So what are sure, right? You can also try on your own with more process, AR process, AR MA process. But takes time, 1 hour, 2 hour, you have to struggle. half a day. It's like a Monte Carlo experiment. Okay, so 1,000 times you can repeat it. But latest, there is an automatic ARIMA with the EViews 12, with latest one. I don't know about the reliability of it. Anyway, so how many model are suitable here? The suitable here, 1, to appropriate 1, 2, 3. So first step is clear, right? This is step number 1. First step is clear. We'll go to the second step. After this, what we have to do? Sir, we need one model, which we call the parsimonious model, to forecast the one model, which is based in forecasting the gold price. Okay, so what to do now? The first step is clear. First step clear, no? Given the condition, the both beta 1 and beta 2 should be significant. This is called as a fitting of ARIMA process. Fitting ARIMA. It's not easy. Okay, sir, why can't we increase more? It's up to you. You take time. Increase the lag and identify both the coefficients should be significant, statistically significant. Can I go to the second step? Three equations. No, one is 212, 311. Yeah, only 212 is there. No. Yeah, two equations. 212, then 311. This is already repeat. 212 already there. No. So this also, this is okay. Anyway, already this is there. We already fit. I will give one model just to hold on. வேணாம் சார் வேணாம் ஷேரிங் இல்லை 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 வேணாம் ஷேர் பண்ண வேணாம் I want to see my file. Sir, அதுதான் வேர்த்து இருக்குது. Okay, we will close it. We'll close it. Okay, so two more. I want you to estimate three more ARIMA process. One is ARIMA 112, which is missing here. Okay, so ARIMA 112. The next one is ARIMA 411, then ARIMA 611. We'll close with this. Okay, I have done many trials to write about. This paper got published actually. I have tried almost 2 to 3 hours I spent to fit the ARIMA model. Okay, so based on that only I just explaining here. So go with 3 more, 112. Both are? So this is okay. Is it acceptable? Yeah, both are significant. What is the next one? 411. Both are significant again. What last one? 611. Very good. Now with this, how many models we identified? How many models identified? 1, 2, 3, 4, 5. 5 model we identified. 5 model we identified. If you are interested in publishing an article in UGC Care journal, group 1, not group 2, especially those who are dealing with the financial markets or even economics also, you can write an article on forecasting the trade or the forecasting GDP or forecasting the inflation, the forecasting macroeconomic variable. Those who are with the capital market, the financial markets, you can also forecast the share price, okay, exchange rate, or might be the gold price, or NSE and BSE indicators, Sensex and Nifty 50, you can forecast using ARIMA. You start writing a paper. There is no theory behind the forecasting, because I told you yesterday, the historical data, especially the TSA, the time series analysis, with respect to historical data, the data speaks itself. Understand? No? And there is no theory required. There is no need to substantiate, validate the theory. But here, just it is the futile or the tedious exercise of just involved into this exercise of forecasting the variable, macroeconomic variable or financial market variable using the ARIMA model. Yes, you can do it, you can fit it, and you can publish in UGC. I'm not suggesting for the group 2, like which is indexed in WS, Web of Science or Scopus. They'll go a little more higher level, the next level, because they won't. This is very conventional model, but still there's a chance of acceptance in the UGC rated journals. The possibilities are there. I'm saying there is no guarantee, but the possibilities are there. If you are interested in writing paper, okay, ARIMA. Because recently I know one of my colleagues published using ARIMA model. There is they have a foreign, service exports. She used the export and import of the service sector. She forecasted and published in UGC ABDC rated journal. ABCC category, right? Not B or A star, C at least. So this model will help you. You are starting with a descriptive, descriptive statistics, right? Now starting with the descriptive statistics. Go ahead with the unit root test. Correct? No, you studied now. We have done it, right? Unit root test followed by fit the ARIMA. Write it well. No need to substantiate. There's descriptives. Right? How characteristics of the variable that you considered. Then go for applying this econometric techniques. Published. Understand, no? Beyond the ranking and the rating, no issues. But take it as a passion and do it. Don't bother whether institution are behind the ranking and the rating. Take it as a passion for a future career. Correct? No? We have to go further. Requirement. Anyway, come to the point. How many models are appropriate? So 1, 2, 3, 4, 5. Okay, 5 models. So the rest of the model just ignore. Let's come to the very important second step. Second step. Out of these 5 models, which is the best model for forecasting? Because I don't want to use the 5 models for forecasting. Only one model used for the forecasting. Correct? No. Okay, how to identify? Second step. Actually, we have to find out which model comes out with the least error. Yesterday I explained, You have to improvise the model. Say, why can we use R square? No need to use R square because we are regressing using the lag term. No need to go for R square value. You won't get much improvement in the R square. Since we are using the same variable and regressing with this lag, so don't go for the R square value. You should go for there are some error minimizing criteria. Make a note. Error minimizing criteria. Okay. So I'm writing here. Error minimizing criteria. Error minimizing criteria. What are they? First one. AIC. What is AIC? Akkai K information criteria. Akkai K information criteria. Second one. SIC. There are many error minimizing criteria. SIC. Squash information criteria. Please make a note. They're very important. Why? What is the purpose? How this model, you have to compare the model and find out which model is the best model in minimizing the error. SIC. One is AIC, the other one is SIC. There are many more. There are many more. Okay, SIC. So commonly used, there are two. There is maximum likelihood ratios based on that one also. We'll see. There are 3, 4. There are 4, 5 criteria there. Okay. The widely used criteria are AIC and okay. Fine. So now, how many models we selected? How many models we selected? 5 model. What are the model? First one is 212. Someone please make a note. I want help from you. One is 212 and 112, 311, 411, 611. Okay. So what you supposed to do? We are going to find out which model is appropriate or best model for the data for the forecast. Okay. Fine. So let me share the screen. We're going to estimate. Okay, I share the screen. Just go to EViews, estimate. So what are the model? First one? First model. 212, right? 212. So I'll go with 212. Yeah. Have you seen AIC, SIC? AIC, SIC. The output you can see AIC and SIC. AIC and SIC. Note the value. Note the value of AIC and SIC. 10.89245. The value of AIC. 10.96623. Squash information criteria. AIC. Note the value of AIC and SIC. Squash information criteria. Have you noted? So next, which model? Which model is appropriate? 3-1? I'm taking your help, no? Second one, which is second one? Which model? 311. Estimate 311 now. And make a note of 311 and make a note of AIC and SIC value. Yeah, please make a note. Make a note of I'll come and check, students, now. I want to see your screen. So you should have, no, you should have estimated. Find out and just note the value of AIC and SIC. Then go for the next model. Once you know down the AIC and SIC, go for the next one. Which model? ARIMA 112. ARIMA 112. Third model, ARIMA 112. Done, no? Please make a note. Very important. So how many models you completed? 3. No. You note on the value of, note on the value, no? Note on the value of how many models? All 5. Very good. So go for the fourth one, 616. 616. No, sorry. 411. 411 and 611. Yes, sir, correct. 611 also done, no? So make a note of AIC and SIC. Okay. So we have to compare, just compare and tell me, compare the values of AIC and SIC and tell me which models AIC and SIC is least. 611. Okay, you do one thing. Students, okay, audience, you estimate and just note down the A's in SIC and tell me which one is the best model in terms of the least AIC and SIC value. Least AIC and SIC value. So that model is the best model or the parsimonious model used for the forecasting the the gold returns. Okay. So the few audience, the few of, I mean, few professors, they are saying it's a 611. 611. So please, everyone just try and come out with it. We'll go for a short break. I'll join with you. Okay? Is it fine? Okay. I'll come back shortly. Thank you.